In this video, we'll introduce the concept of a capital tax factor and capital salvage factor for the purpose of calculating the present worth of an investment. By way of introduction, I will first talk about how we treat cash flows using this capital tax factor and capital salvage factor method. So, as per usual, we'll have some first cost when we invest in a machinery or other type of investment. And the method of finding the present worth of the first cost is to simply multiply by this thing we call the capital tax factor. So you may recall from other problems or previous videos that when we make a purchase or an investment in an asset, we have some initial expense, but then we also receive a benefit over the life of the asset by way of tax savings as a result of the depreciation expense. This magical capital tax factor rolls all the effects of the company's tax rate, depreciation, and interest rate into one calculation so that you don't have to manually think about what is the depreciation calculation for each year, what is the tax savings for each year, and then convert those to a present worth. The capital tax factor does that all in one step. This capital tax factor that we'll use is actually relevant to Canadian tax. So this value incorporates the half-year rule inside of it. The next thing that we'll have is we may have in a project, we may have other, let's say, savings that are not tax depreciation related, other savings or other expenses. If we have other savings and other expenses, we'll look at those cash flows, and the way that we treat those in the after-tax analysis to calculate the present worth is we multiply by 1 minus the tax rate. And this is something that perhaps you've seen before by now in the course. So we take these cash flows, multiply by 1 minus t, that we can then call them after-tax cash flows, and then we have to convert to present value. And then the last thing I want to talk about is the salvage value. Now, if you think about the first cost and then having an associated tax savings in the future, the salvage value also has implications related to the depreciation expense and the resulting tax savings. So we have this something called the capital salvage factor, which incorporates all of a sudden that loss of future tax savings that we don't have anymore because we've disposed of the asset. This capital salvage factor works sort of at that point in the future to convert that salvage value to an after-tax value, but we still need to convert to the present value. So this sort of outlines the general procedure for approaching an investment problem in an after-tax method. So I would encourage you at this point, pause the video, read this particular problem, and when you're ready to see the solution, restart the video. So in this problem, we learn of a company that is wanting to buy a piece of equipment. It's a bottle capper. And this bottle capper, we draw it on a cash flow diagram, looks like this. It's an initial investment amount of $10,000. We have a time horizon of 5 years. this capper will result in annual savings of $4,000 per year. And we're told at the end of 5 years, we can sell the equipment and receive a salvage value of $2,000. We also learn in the problem that the company has a tax rate of 50% or 0.05. The depreciation rate for this particular type of property or asset is 20%. And the company uses a MAR for after-tax calculations equal to 12%. So the task that we have is to take this cash flow diagram as described in the problem, combined with the company's tax rate, the depreciation rate for the asset that we purchase, as well as the company's minimum attractive rate of return, and decide whether or not this is a good investment for the company. So the way that we do that, as with more simple problems without tax, we can look at a present worth type analysis. So we'll first look at the present worth of the first cost. The present worth of the first cost is simply equal to our negative 10,000. It's important in problems like this to make sure we use the correct sign. So down arrows in the cash flow diagram are expenses and they are negative in our calculations. Up arrows are positive. And we're simply going to multiply by this magical capital tax factor that makes our life easy, taking into account tax, depreciation, and interest rate. In this case, we'll use the company's MAR as the interest rate. So what is this capital tax factor? Well, just as an aside, we'll write what this is, and if you look on the inside front cover of a finance or engineering economics textbook, it will give you the formula for the capital tax factor. And I'll write it here. And as you'll see, it's not a simple calculation, or a simple formula. Okay, so this is the formula for the capital tax factor. And I would encourage you at this point to plug the numbers in. Here, I is equal to our 12%, depreciation was equal to 20%, and our tax was equal to 50%. Go ahead and plug these numbers into this formula and see if you can come up with the value for the capital tax factor of 0.70424. Most of the time, with somewhat normal values for depreciation, interest, and tax, you'll end up with a capital tax factor somewhere around 0.7. Okay, so we'll multiply this out and we end up with negative $7,042. So this is the present worth of the first cost after tax. The present worth of the savings, so the present worth of this $4,000 yearly savings is going to be simply the 4,000 times 1 minus the tax rate times, now remember this is an annuity, so I need to bring them all back to the present, and I'm going to use the company's MAR as the interest rate, so I'll use the P given A factor for 12% and 5 years. Work out what this is, so it ends up as 4,000 times 0.5 times the P given A factor, 3.6047. You should be able to arrive at this number, this time positive, so the present worth of our $4,000 before tax annuity over 5 years, taking into account tax, and then taking into account the time value of money using the MAR as the interest rate, I end up with a present worth of the savings of $72.09. The last thing I need to consider is the present worth of the salvage. And in this case, the salvage value was $2,000. I'm going to multiply that according to our introduction instructions times the capital salvage factor. And then we're also told we still have to convert that to the present. So I'll multiply all of this by, this time, not a P given A, but a P given F factor for 12% and 5. We use P given F because this is now a discrete payment at one point in time, not an annuity. So I'll write this down. And I should also say that the capital salvage factor, slightly simpler formula than the capital tax factor. I'll put it down here. 1 minus TD divided by I plus D. Again, plug these numbers into this capital salvage factor and see if you can get the same value that I did, which is 6.6875, and my compound interest factor for P given F is 0.56743, which gives me a present worth of the salvage of $780. So now all that remains is for us to find the total. So the present worth for this cash flow after tax, our present worth will be the negative 7042 plus 7209 plus 780. So this, and this, which gives us a present worth of 947. So recall that when we do a present worth analysis using the minimum attractive rate of return as the interest rate, we end up with a healthy positive number. That suggests that we should, in fact, buy the equipment. So this problem illustrates present worth analysis in an after-tax world. It's also possible to do annual worth analysis. And just by way of comments, I'll suggest that everything up here is very similar in terms of how we guide someone in doing an annual worth calculation. So the only difference being that if we convert our first cost using the capital tax factor, we then have to convert that to an annuity. Any savings or expenses that are an annuity don't need to be converted. And our salvage value needs to be, again, converted to annuity rather than a present value. So the procedure for an annual worth analysis is very similar to the procedure for a present worth analysis using the capital tax factor and capital salvage factor. But both of these factors will save us a lot of time in especially determining the tax-related effects due to the depreciation of an asset.